Welcome to our video tutorial for question 3 of our daily review. In this question, we are describing and finding locations of numbers on a number line. The more that we do this, the greater our general understanding of the location of numbers will be. One thing to note very quickly here as I draw a number line out here, similar to like you see there in question 3, we don't actually have labels given to us on this number line. And that's actually a really important part of this question. Part of what you're going to be asked to do in this is to pick a scale or a way to label that number line. And it is going to depend on the numbers that you are given and the numbers that you need to place on that number line, what that scale is. And so we'll take a look at some examples of that here. Let's go ahead and start with a really simple example. In this case, if we had the numbers like 3, 5, and 7, those are all pretty simple to put on our number line. A quick reminder for us as we work on creating scale for our number line, we need to remember that our smaller numbers always go to the left and our larger numbers will always go to the right. However, what numbers are in which spaces might be different depending on that scale, and we'll see some examples of that. In this case, since I'm just working with 3 positive integers, I could simply count by ones on this number line and then label those 3 numbers on the number line. So you can see that I've done that here, and I'm simply going to place the number 3, I'm going to place the number 5, and I will place the number 7. That's pretty simple. Now that happens to be 3 integers. What happens if we get positive numbers, negative numbers, or decimals? Well, we might need to change the scale on the bottom. So let's go ahead and look at the next 3 numbers that I have here. Here I have 0.25, I have 1/4, and I have negative 2.5. Well, I can see 2 problems right away with the scale that I have down below. The first problem I see is that numbers 1 through 14 do not include any negative numbers. So that means my purple number, negative 2.5, cannot go on this number line. The second challenge that I see is that because I'm counting by ones, I'm not going to be able to accurately place a number like 0.25 or 1/4. So I probably need to change the scale, and in this case I'm gonna go ahead and start with a much smaller number like negative 3. Now I don't need to start with like negative 100 because I don't need to go that small, but I need something that's going to include that negative 2.5. You're also going to notice that I didn't count by ones on this number line. In fact, I skipped 4 spaces for every one. Or another way to think about that is that I'm counting by 1/4. And I did that so that I could easily place my values of 0.25, 0.5, and 1/4. So let's go ahead and start building these numbers out on our number line. In this case, I have 0.25 would be right there. 1/4 would actually be in the same place because 0.25 and 1/4 are exactly the same. And that's one of the things that working with this particular problem will help us with, is continuing to make comparisons between fractions and decimals. And finally, I have negative 2.5 that I could place on this number line. Let's go ahead and look at one final example of some sets of numbers here. Here we have 4, 9 halves, and the square root of 27. Again, in this particular example, we don't have any negative numbers, so I don't need to start at negative 3 like I did before. I'm going to constantly be thinking about what do I need to count by. So I have positive numbers. I am going to start to maybe think about, well, how big are those positive numbers? What are those numbers around? And in fact, in order to do this, I might want to make some calculations first. And after I've made those calculations for this one, I'm actually going to choose to count by 0.1. And I'm just offsetting here because I need a little bit more space to write. But I'm just counting by 0.1 for each one of those lines, and that's going to allow me to include all three of these things really accurately in our number line. So I've started at 3.9. I've gone all the way up to 5.2. I'm counting by 0.1 each time, or 1/10 each time. My first number is pretty easy to place. 4 just is going to go directly above 4.0. Next, I have 9 halves, and if I do some work with 9 halves, I'm going to realize that 9 halves, or 9 divided by 2, is actually 4.5. So I can put 9 halves right above my 4.5 mark. And finally, I have the square root of negative 27. And we've done some work with square roots on question number 1 and question number 2. And I'm going to know right away that negative 27 is an irrational number. And it is an irrational number. I know that because my perfect squares are 25 and then 36. So 27 is not a perfect square. That means that I'm going to end up with an estimated answer. I'm never going to have an exact answer because it is an irrational number. Remember, irrational numbers means that that decimal repeats, it goes on forever. So I'm simply going to estimate where that might be. And in this case, I've done some work on my calculator, and we've talked again in question 1 or 2 about how to do that on your calculator. And I've found that the square root of 27 is 5.19, and there's a lot of other decimals that go along with that. 196,15242. Again, that's an estimate. So I'm simply going to estimate that location, and I'm going to put it really close to that 5.2, in between the 5.1 and the 5.2, and that should represent 5.19. Remember that any irrational number will always be an estimate. It will never be an exact number, and therefore it can never be an exact location.